All right, so today we're talking about extrema and average rate of change, okay? Make sure you guys get down to goal in that goal section because it's always good to kind of know, what is expected in this lesson, what you should know by the end of the lesson. So that way you can just kind of do your own type of tracking yourself, okay? These are on page 10 and 11. So make sure when you get the opportunity, you add it to your table of contents that extrema average rate of change is going to span pages 10 and 11 in your table of contents. All right, so by the end of the lesson, you'll be able to determine intervals of increasing, decreasing, or constant, as well as extreme. And you'll also be able to determine the average rate of change of different types of functions, okay? So a function can increase, decrease, or remain constant over a given interval. Increasing being that, the graph is going up. Decreasing, the graph is going down. Constant is neither going up nor down. It's just going, straight across. Okay? And a function, when it changes from going increasing to decreasing, at that point where it changes is called a critical point. Okay? Now, a critical point can either be a relative min, an absolute min, a relative max, or an absolute max. Okay, so they can have one of those four different types of names, those critical points. And in general, a max or a min is called extrema. Okay, so if you ever hear me say, okay, what's the extrema, I'm basically asking you what's the max or what's the min. Okay? So in this particular example that you guys see on your paper, from this point to this point it's increasing, you see where it's remaining constant, increasing, and of course decreasing. We always read from left to right, okay? Never from like an actual max or min, but we always read from left to right. So if the graph is going up, it's increasing. If it's not going up or down, it's just staying level, it's constant, and then if it's going down, it is decreasing. So how will we label this, okay? We're going to say that the function is increasing. We always base off of the x values, okay? So we start at -5, and we increase until what value? -2, okay? And this here is going to have brackets around it, okay? It's always going to have brackets. Unless you just have to have an open circle in it, That's different. Is it increasing anywhere else? Yes. From what to what? 1 to 3. Okay? And just like how we did on multiple domains and we connect them together with the union, we do the same thing when we're increasing and decreasing. So it's increasing again from 1 to 3. It's decreasing 3 to 5. Remember, we always use our x values to determine if it's increasing or decreasing. And where is it constant? -2 to 1. Simple enough, right? No. Looking at the x's. Not the y's, the x's. So we start with the far left x value, -5, increasing up to -2. Constant from -2 to 1, increasing from 1 to 3, and then decreasing from 3 to 5. Exactly. Neither increasing or decreasing is where it's constant. Okay? So far so good? Alright. So we're going to use these graphs to estimate the intervals in which the function is increasing, decreasing, or constant. And then we're going to identify any extrema. What does that mean? Maxes and mins, whether they're absolute or relative. And I'll also distinguish between what's absolute and what's relative later on. Okay? So we always read from left to right. Okay? A curve. I don't know if you can tell up here, but on your paper, that is an arrowhead. Okay? So, it's shooting off into what? -infinity. So from -infinity to what value, what is it doing? What is it doing from -infinity going to the left? It's going down, meaning it's decreasing. And it's going to be decreasing from -infinity to what x value? What x value is it getting close to as it's decreasing? 0. Just like before, we always put a parenthesis around infinities. It doesn't, but we're not talking about domain-wise. We're just talking about intervals increasing and decreasing. So what's happening after 0? The graph is shooting up that way. What's happening as we read from left to right? It's decreasing. Because technically, the graph is coming from somewhere up here, but it's still going down, isn't it? So it's still decreasing from 0 to infinity. So think about it. As you read from left to right, what's the graph doing? Think about it. If you're tracing along, what is your hand doing? What's your pencil doing? If your pencil and hand are going down, decreasing. It's going up, increasing. It's just kind of staying flat. It's constant. What about over here? Reading from left to right. Decreasing. From what to what? Careful. What those arrowheads mean?
Oh,
Yes. It's going to get bigger and bigger going this way. So from negative infinity to 2. So what's happening after 2? From 2 to what? Infinity. The one thing that could really trip you up is if you try to read it based off of the y's, it's always based off of the x's when you're increasing and decreasing and constant. Okay? Now, extrema. You only have extrema if it changes from increasing to decreasing or vice versa. In number 1, or the first example, is it any extrema? No. And don't let these little humps right here fool you. If it's not changing from increasing to decreasing or decreasing to increasing, there's no extrema. What about another one? Yes? What kind? It's a min. And more specifically, it's an absolute min. Absolute means that is the absolute lowest point on the graph, or vice versa. It's the absolute highest point. Okay, there's no other values lower than, I guess that might be like -9. So that's why it's an absolute min. Now, there are other parts of the graph that go lower than that. It'll just be relative. Okay? Questions? You can only have, at most, one absolute max and one absolute min in the graph. You got multiple relative ones, though. All right? I'm still recording. Good to go. There are no questions? Fly right on through. All right. Some functions can be seen easily, like the last ones. However, for the ones that are not as easily seen, we use our graphing calculator. And we're going to cross our fingers, and let's hope that my calculator doesn't freeze up on me like it did on Friday. We're going to use our graphing calculator to determine the exact intervals in which the graph is increasing or decreasing. Okay? So, looking at this graph, we're going to definitely need to plug it into our calculator, okay? So, that. Our function is x to the 4th, yeah? So I got x to the 4th. Remember, if yours just does the little caret, it's fine. But if yours does what mine does, you got to get out of the exponent. So read the rest to me. All right, so we're going to type that function in. Don't know who has your calculator, especially using one of mine. So what's a good habit? Zoom. 6 standard. So let's see what this looks like. It should look exactly like my other graph. That was on my paper, yep? Beautiful. So we can kind of see reading from left to right that what's happening? Are we increasing, decreasing, constant? Decreasing to some x value right here. But it's not like exactly at a line. So you guys remember how to do this from Friday? I taught you through it. Is that a max or a min first? It's a min, more specifically, it's an absolute min, it's the very lowest one. So I gotta go to second, what number's the little button? Trace. Second trace, which is the 4th button at the top, allows you to pop up all these different values. Now, last class we did 0 and we did intersect, I think. But you see how there's max and min there? That's what we use those options for. So we're looking for a min, right? So we're going to go down to option 3, click enter, and then it does the same left bound, right bound it did when we were trying to find the zeros. This time, we're just going to go to the left of that minimum point. Okay? And you don't want to go too far to the left because then the calculator might get confused. So we're just going to go just to the left of the minimum. Is everybody with me? I press the over arrows to get to the left. Click enter. Now right bound pops up. What does that mean? Gotta go to the right of that minimum. Not too far, because if you notice really close to this minimum is a different extrema. So you don't want to go too far that again the calculator gets confused. And you click enter again. Now yes, I have this nice little luxury, which is good because I'm trying to show this. Your arrowheads should be in between wherever your minimum is. If it isn't, then that means you did something wrong.
Why didn't it show me?
Now, if you don't have these vertical lines, it's okay. It's just, I have like the most advanced version of this version of graphic calculator. So if you have your own, you might have this luxury as well. If you don't, it's okay. The arrows are still there. So you just kind of got like, yes, it was. Click enter one more time. There's the minimum. There's the x value. It definitely wasn't -1, it was -1.3. So, back to our paper. This graph is decreasing from what to what? Negative infinity to -1.3. What's happening after -1.3? It's increasing. We know it's increasing from -1.3 to some value. It looks really close to 0, but I think it's a little off from that. So, back to our calculator. I'm doing this one with you. The second one is going to be on you. Okay? Max or min? Max. So where do I go? Aaliyah, where do I go? Second trace. Maximum, option 4. Now I gotta go to the left of this maximum. I want to be closer to the maximum than I am to the minimum, so I want to move it closer and click enter. Right bound, go to the right of the maximum. Are you at left bound? You move the left and right arrows over to get closer to.
Why do you do that? Like, why don't you just go to the point maximum?
Oh, because this feature, you have to basically set the intervals in which the calculator has to know where the maximum is. You just can't click enter 3 times or else it's not going to work. You actually have to center it around the maximum. And now we guess again. So what would that be about? 1.7? You think it's what? Like completely? Like if your screen went, it's probably the battery's done. Probably. What's happening next? I gotta find another min because it is decreasing. So it is decreasing from 0.17 until some value. I know I'm flipping back and forth, but hopefully everyone's able to follow me. So I have another min. Second trace, option 3. You go to the left of that minimum. Again, move your cursor closer to the minimum so the calculator knows I want this point, not the max, to that minimum. So I'm going to get close to it. Right bound. Double check, make sure my arrows lie in between, and guess. So it's decreasing to 1.13. What's happening after that? until infinity. Woo, made it through. So increasing from 1.13 to infinity. Now I notice, you know, it may take a while, but once you get the hang of finding your maxes and mins, you'll be flying right through it. Okay? So what I want you guys to do is I want you guys to do the second one. Find my intervals of increasing and decreasing. And then after we do both of these, I'll go back and we'll label. Okay? I found my minimum to be 0.33. Okay. So my minimum is located at 0.33. Where was my max located? -1. So what's happening? What's happening before -1? It's what's happening from after -1 until and then it's doing what? Increasing again from 0.3 until what? Infinity. Good stuff, right? Were you faster this time with finding the max and min? Okay. Don't worry, the more you do, the faster you'll get. Now, real quick, let's classify these extrema. Okay? This one right here is a what type? It's an absolute minimum. Is there anything lower than this? No, it's the lowest one. What's this? I mean, like, classify it. It is a max, but it's going to be relative. Because there's other points that are higher than this. So it's a relative max. What's this one? Relative min. Very good. Over here, what was this maximum? Relative. And this one here? Relative. Good stuff. Questions up to here? All right. Now, optimization is the application of mathematics when one searches for a maximum or minimum quantity given a set of constraints. Now, before y'all get there, you're like, oh my gosh, I hate word problems. Okay. All right, I've heard it. Already heard it. You ain't gonna love them, but you're gonna be able to tolerate them a little bit more. So here we go. It says, suppose each of the 75 orange trees in Florida groves produce 400 oranges per season. Okay? So, if each of the 75 trees in Florida produces 400 oranges each, how do you figure out the total number of oranges? You multiply, right? Keep that in mind. Keep that in mind. It says also, suppose that for each additional tree planted, the yield per tree decreases by 2. Okay? How many additional trees should be planted to achieve the greatest total yield? So let's recap. How do we figure out the total number of oranges we have? You multiply. Okay? Now it says, suppose that each additional tree planted. How many trees do we have right now? So how do I represent additional trees planted? Add, what are we adding? Just one tree? Can I add 2 trees? Can I add 10 trees? X. Yes. So we have 75 plus X. However many trees there are, including the additional trees. We're going to multiply that by the number of oranges. Now it says the yield per tree decreases by 2 oranges. 400 minus 2x. Yes, because think about it, guys. However many trees we have, we're losing 2 oranges per each additional tree. So if we have 5 extra trees, we're losing how many 10 oranges from, you know, the original 400 that we would have had we just stuck to 75 trees. Okay? So this is our function right here. It's not a nice one with x squares and x's, but it's a function. Okay? We got our function here. Now it asks us how many additional trees should be planted to achieve the greatest total yield. What does that mean, the greatest total yield? Max. We're looking for a maximum here. So this is our function. We're looking for a max. And more specifically, trees, which is what variable? X. We're looking for the x value of our maximum. Okay? You just got to break it down, a sentence by sentence, to figure out, okay, what's the equation? What is it asking me to do? And how do I do it? Question by question. What is it asking me to do? And how do I do it? So, let's go ahead. Let's type this in. Pull up our calculator. Type in the function. And I want you to find the maximum. You guys know how to do it. So find the maximum. When you type it in, yes, you gotta fix the window. Because think about it, guys, we're at 75 plus x. And we're multiplying that by 400 minus 2x. So yeah, we're gonna have to open up this window some, because a regular standard window ain't gonna cut it. Okay? Now, a feature that we have is when we go to Zoom, we have a zoom out option. Sometimes that works, sometimes it doesn't. But that's usually a good place to start. So let's zoom out. You'll have to click 3 and then click enter, or else it's not going to zoom out anymore. We're going to zoom out some more. Or let's see, let's look at my window. It only zoomed me out to 40. Well, that kind of didn't help me none. What's the x value you guys want to pick? 5. It's going to be smaller than what we already have, so it's not quite going to be. We know it has to be bigger than 40. We have to see this function. We got 400, we got 60. That's a big difference. Let's do 200. Now, how do you know? I have a feeling this question is coming. How do you know what to open your window up to? Honestly, you're gonna just have to kind of go with it. Okay? You're trying to basically see where the graph is. You don't want to do anything too ridiculous. Okay? Like 1,000. That's a little crazy. Okay? A little crazy. But increasing by tens is going to be a little long. It's going to take you a while. Okay? So let's see. Let's open it up. I'll open it up to 200. Hey, I got something. There we go.
Mine is an error.
Make sure that you still have like your min is always smaller than your max. That's usually what an arrow pop up. So play with your window. You're trying to see this curve, okay? Keep opening it up. Double check on. So we got to open up our window pretty big in order to see this. Also, if we had foiled this out, okay, because this is nothing but 2 binomials that we could have foiled, correct? Okay? You got the same window settings as I do? If we have foiled 75 times 400 was like 30,000, I think. So we definitely had to have something else a little bit bigger. So it was going to be pretty big. So when we look at the graph, we have a maximum. Find it. Find that maximum value. Find that x of that maximum. About 62 oranges, right? Now, if your x value is not exactly like mine, it could be a window setting, but it is 62 oranges here. Or, I mean, not oranges, trees. Questions? the last little bit. Okay? The average rate of change is nothing but the slope between 2 points. Okay? That's literally what average rate of change is. It is the slope between 2 points. It's basically how fast is the curve increasing between 2 points. So it's literally slope. Because what does f of x mean? Y. So you are finding the y value of your second x value and the y value of your first x value. Very simple. Find the average rate of change for this function on the given interval. So all we do is we plug in -2 into the function. We did this the last class, I think, or 2 classes ago when we were evaluating functions. Just be careful of your signs. I always like to include parentheses because it lets me know I am cubing what number? -2. -2 cubed is what? -8. Think about -2 times -2 times a -2. What's 3 times -2? 2 negatives make a what? Positive. So what is this number? 2. Okay? I'm going to do the same thing with -1 and plug that in. What's -1 cubed? So I have a negative -1. 3 times -1? 2 negatives make a positive. What's this value? -2. So I need my y's in order to find my slope. F of x2 is -2. F of x1 is a +2. So I just plug into the formula. -2 minus 2 all over -1 minus the -2. Simple as that. What's -2 minus 2? -4. 2 negatives make a positive. What's -1 plus 2? So the average rate of change from -2 to -1 is a -4. And just by doing that, if we were to graph this, then that means that from -2 to -1, this graph would be doing what, you think? If you have a -4, it's going to be decreasing. Okay? Yep, it's the slope. So the slope from -2 to -4 is going to be negative. The -2 to -1 is going to be a negative, meaning it's going to be going down. Okay? Do from 0 to 1. Do that interval. Find the average rate of change of that interval. So when you did this, what was f of 0? It was 0. What was f of 1? 2. So when you go to plug it in, it should have been 2 minus 0 over what? 1 minus 0. What's your answer? 2. So the average rate of change from 0 to 1 is 2, meaning that from 0 to 1 it should be increasing. Yes?
Okay, I'm just going to go more and quote the numbers. Like, I got my 0 and 2, but how to put those numbers on.
Put right into here. So this is the form that we're plugging into to find our average rate of change. So when we actually take 0 and plug it into the function, we're finding this value right here. And then when we plug in 1, we're finding out what this value is. So that's what those numbers are from. They're in our numerator. And if I graph this, you will see that from -2 to -1, isn't it decreasing? And then from 0 to 1, isn't it increasing? And that literally is the slope of 2. Rise up 2